Good afternoon, everyone. You're a true data enthusiast, right? Lunchtime, you're attending a session, deep session on data. So very impressed. So thank you very much for coming in. To start off, so I'm Pratim Das. I run the Data and AI Solutions Architecture team at Microsoft for global and strategic customers. And my co-speaker is Blesson, who will introduce himself.
Hello, everyone. I'm a cloud solution architect focusing on advanced analytics and AI within Pratim's team.
Good. So today we're going to spend some time. The first half really rushing. We're going to try to go through everything that we have on Azure in the whole landscape for data and AI. And then Blesson is going to stitch everything I have talked about as a demo. And hopefully, with today's internet connection, hopefully it'll work. So introduction to the ML life cycle, right? So at the end of the day, what are we trying to do? Business insights. Not only business insights, what we're trying to do is business actions, really. How do we take data to actions? That's everyone's goal, right? Business goals. And if you think of the evolution of computing, you know, we had like hardware, and then we have virtual machines, then we came cloud computing, then you get BI and reporting, and then came advanced analytics. And then is the ML and AI, where we started doing predictions. Absolutely, thanks, Blesson. And what we're going to talk through is from not only knowing what's happening in my inventory, is my inventory going to run out, or you know, is my workforce optimized? Not only that, I want to predict when is my inventory going to run out, or what do I need to do with my workforce to get the maximum impact. So this, in one screen, almost impossible to do. We tried to put together everything on Azure Data and AI platform. From the left to the right, we start with ingestion, bringing data in and on Azure, and then how we store it, how we operationalize it, how we derive analytics and insights from it, and finally, how do we take actions with AI and ML. So, it's impossible for me to go through each of the service. So what we're going to focus on just one service in the ingestion series, so Azure Data Factory. Most of you probably are using it in this room. Just a show of hands. Is anyone in this audience using Azure Data Factory? Great. Right. So we've got a lot of people who needs to use very soon. So these are the use cases you can solve. Modernizing your enterprise data architecture, data warehouses, bringing data from various places and running insights. If you have SQL Server SSIS, how do you migrate to Azure? If you're running a hybrid multi-cloud integration pattern, how do you do that? Azure Data Factory has got various connectors, 90-odd connectors for various services that you can bring data to Azure using that. The other one, streaming data, right? How do you bring data from IoT devices? So here we provide, in Events Hub, we provide all sorts of APIs for you to connect. So it doesn't matter what skill set you have, you can just start writing your code. It's compatible with Kafka, for example. If you have an agent, it's like no code. You can just connect your connected to event hubs and start consuming data. And then now I'm going to quickly jump into the Azure storage services. So first one, the most common is Azure SQL Server, and everyone knows about it, so I'm not going to spend too much time on it. But remember, SQL Server today is at hyperscale. Other options are SQL Server serverless, as SQL Server on the edge, and you also have SQL Server in a hybrid scenario as well. What I'm going to focus on, Azure Data Lake Gen 2. This is Data Lake, right? So this is how we make our blob service available for data lake analysis. What do you need for a good data lake? You need massive scale. You need to go into granular data, right? So data warehouses where you have aggregated data, but if you want to really go to the nth grain of data, data lake is very good. You need great performance at scale. You need integration to various tools, and you need it to be cost-effective, TCO. So, we're not on our own. We have a huge partner ecosystem, and you'll see various partners, starting from data migration to various Hadoop engines, Spark Hadoop engines, and BI platforms that can also integrate with Azure Data Lake, in addition to our native services as well, such as Power BI. And the next one of my very favorite, is Azure Cosmos DB. How do you build planet-scale applications? Every application or app we build could be a mobile app, it could be globally distributed these days, right? So the world is very, very small place where you build something, suddenly your consumers are all over the world. How do you do that with Azure Cosmos DB? Some of the key things in Cosmos DB is it provides a the learning curve on Cosmos DB is very, very small. So it doesn't matter you're a Spark developer, MongoDB or Cassandra API, you can use Cosmos DB. And guess what? It not only does key value, it is one platform that allows you to do column family, document family, and also do graphs, such as Gremlin. And the various use cases, these are the top 10 use cases that we see, top 10 reasons why we see customers use Cosmos DB. I'm not going to go through all of those. One of the very interesting was 5 well-defined consistency levels, right? And provides big data workloads with a high availability and reliability. The other very common use case that we see customers use is migrating their NoSQL applications using the wire protocol Cosmos DB provides. One great example here is how ASOS uses a Lambda architecture, a hot part and a cold part, to do run analytics for thousands of their customers. The other one, interest time, we're doing okay, is Azure Search. This is an architecture by the Met in New York, where they make millions of their artwork available to millions of customers worldwide online. And Azure Search is used over here, and it finds out relationships that humans can't normally figure it out, like really artifacts to artists. It joins those dots. This architecture provides how this has been done. Now jumping into the next column of services such as database and analytics. So we went to there. So we talked about Cosmos DB. One of the great features of Cosmos DB is change feed. So you ingest data with very, very high throughput from IoT scenarios in Cosmos DB. But then you can consume the data using change feed through various processes like event notification. You can use Azure Function, for example. You can run Spark stream processing on top of it. You can also sync the data, for example, to Azure Data Lake. This is an example of Jet, who is one of our customers in the automobile industry. And you see how they use Azure Cosmos DB in their checkout process, right? So various functions taken off the back of change feed to do various things. One, to do tax calculation. The other, to do payment. The other, to do fulfillment. All done from one stream. And Microsoft, also, especially on the storage, we love open source. So if you look at the various services that are available as managed services on Azure, for example, MySQL, Postgres, MariaDB, all through the manageability that Azure Cloud provides you. Guess what? You must be confused. I've been showing so many services that you can use on Azure. But really, there is a very prescriptive way based on exactly what business value are you trying to get out of Azure. This is a prescriptive documentation, tells you which service to use when. Now, for the main part of it, Azure Analytics. So here, there are various services that provides you advanced analytics capabilities. The first one is Azure Databricks. So, hold on. So this is Apache Spark, and Azure Databricks is the first-party service on Azure, and it allows folks like data engineers, data scientists and business analysts to all come together under one platform. And if you look at the various use cases that you can solve with Azure Databricks, for example, in retail, price optimization, in financial services, fraud detection, industrial IoT, security intelligence, personalization also in retail, and advertisement, sentiment analysis in the social media scenario. And finally, what we realized, what customers want to do, rather than stitching various services together to get to the business outcome they're expecting, they want everything to be made easy. It's not about getting to the cloud, it's about getting value out of your data. So you saw the recent announcement about Azure Synapse Analytics. Here, what we did is, so we looked at all our platform and everything we have, and we put a common data model and an enterprise security architecture underneath. And then the very best things that you all love, for example, data integration from various services. And then the most common languages, for example, Spark for your non-relational data, and for relational data, SQL. You can also have T-SQL for your streaming data, and then ability to run everything from a studio using the language of your choice, putting all those together. So this service is in private preview now, so look out for it. So what we decided, this will simplify your data to business value very, very easily. That's a quick preview of the Azure Synapse Analytics Studio. With that, we're going to jump to Azure Machine Learning, and without wasting any time, hand over to the demo and Blesson to take over. Thank you, Blesson.
Thank you, Pratim, for taking us through. What happens once you have cleansed the data? What do you do with it? Is the biggest question these days businesses face, because they want to know how valuable that data is, whether they can get any insight out of it. As Pratim alluded in the first screen, like there was a period when there was business intelligence that was used to find out what happened in my business. Now you want to do the next step, which is predicting what is going to happen to my business. And for which, if I look, there is a plethora of services that Azure offers, whether it be at the hardware level or whether it be at the pre-trained model level. We've got a lot of services. A pre-trained model will be something like Azure Vision, Custom Vision, or speech, language, etc., which has been pre-trained. And what you could then do is use your data on top of it and customize it according to your business needs. That is a pre-canned solution. But if you wanted to use something that's not pre-canned, you want to develop on your own, you have, again, CPU, GPU, and FPGAs available as hardware. And the key service that we will be talking today about is Azure Machine Learning. But we are open to any of the popular frameworks that you may want to use, or any of the tools that you are interested in using. So what exactly is Azure Machine Learning Service? It's a cloud service, and it has got ability like a Python SDK, which will allow you to prepare the data, model, build your model, train the model, and then be able to deploy it. Okay, it is all encompassing. The first step is where you are using your data and finding out which data will be able to give you the value that you are trying to predict. And then you create a model out of it, publish it, and then the end user is able to use that endpoint for the prediction. If I take a drill down into what Azure ML Service offers, it has a model space, experiment, pipelines, compute targets, image deployment, and data store. But as a whole, there are two splits to it. Azure Machine Learning, you can run it for free. If you're running the basic version and you're deciding to use just the open source, then you can go with the basic version and you're not charged for using the workspace. But if you go for the enterprise edition, that's where you get the designer view and as well as the automated machine learning feature. So under the hood, that's how it looks, but I just don't want to go through all of that in the interest of time. So How many of you have heard of automated machine learning? Just quickly, yeah, few in the room, just to get everyone up to speed. Automated machine learning is a place where you are allowing the machine to decide which algorithm to use and how the feature engineering needs to be done, as well as hyperparameter tuning. Okay, so let's take this example. This is what I'm going to demo today. How much is this car worth? How do I predict this? If I were to use automated machine learning, what it really does under the hood is, when I say feature, are the attributes that that contribute towards the final result, the pricing. Okay, so those are the features I believe as an individual that will contribute towards finding the price of the car. Then I may use different algorithms in the regression space because I'm predicting a value. Then what are the parameters that needs to be tweaked, hyperparameters that needs to be tweaked with that? So you would select those features, car brand, year of make, and mileage, and then you could be running through different algorithms to find out the best fit. At the end of the process, you would come up with a pretty optimized model, which has an accuracy that you decide at that point. If you look at this, this is the step. I get the data from once it has been processed using one of the technologies that, or some of the technologies that Pratim mentioned. Once that's done, you do the feature engineering, and all this piece that you see over here in this particular part, feature engineering, algorithm selection, hyperparameter tuning, all that is done within automated ML, as long as it is in one of the three spaces. With it, currently we support regression, classification, and forecasting. So with that, you would be able to then create your own models. So we'll go back and look at how to create one of these models. Check the time. Yeah, we've got 14 minutes. The first step is you go into the Azure portal, and then what you would do is hit create. I hope it works fast enough for me. So I type in machine learning in here, and this is how I would create a workspace. So I just hit create. At this point, I will say Big Data. I'm setting the location where I want this to be. I'm using an existing resource group. And this is the two ones that I talked about, Basic and Enterprise Edition. In this case, I'm going to take Enterprise Edition and hit Review and Create. So the job has been submitted. That's all right. So it's creating the workspace at the moment for me. In the meantime, I'll just go back into a view of the data lake. So I've got the data lake here. I've got a pre-processed data, which has come in, and I've put the data in here, which is called carprice.csv. If I were to take a look at it, it would have something like along the lines of this one. There's a slightly different data, but this is how it would do. It has got the make of the car, it has got the fuel type, doors, body, whether it's saloon, etc., rear wheel, front wheel drive, weight of the car, and so forth. I'm just assuming those are the features that would help me predict the price of the car. Okay, so let's go back in and see. Under the hood, it is creating a lot of stuff, a lot of things. Let's look what it's creating. If I were to look. So first thing, it creates a storage, a key vault to store any secure information if you had one. It also creates various components. The next step is, which is underway, it would go and create a workspace for you. So when this is complete, we'll just go in and go to that resource. Let's give it a few minutes, probably. Any questions in the meantime about what we are trying to achieve over here? We're trying to predict the price of the car, and ultimately we want to import this information into Power BI so that the end user will be able to visualize it. Okay? Yeah, go for it. Wait.
Hi. The solution you have here is really great for people who do not have deep technical expertise. But
Yeah.
then in a case where, say, you have a regulatory environment, that means you need to understand everything going on in the middle end. This is more of a black box. So do you get like a bit of an explanation of the path that the AutoML has taken?
You mean from the point of view of just a second? Are you stating that the algorithms that
Model validation.
Yeah. So there is something called as explainability within automated ML at the moment, within the whole service itself. What we have done is, when I was working with one of my customers, the time taken to build a model, and then like if you data cleansing takes most of your time, like at least 70% of your time, and then finding the right model and then operationalizing it would take another 20-25%. But explaining to the end user what exactly this model does is a very key problem, and it takes time and effort from the data scientists and the business community that was involved in the development to go through that process. So what we have done is, listening to our customers, we understand that there needs to be some way to explain what algorithm was used, what parameters, what features were used, how was it tuned, etc. So we have given that ability right now. With a click of a button, you can say that I want an explainability of my model. I want a clear explanation which algorithm was used, which feature set used, and etc. Okay?
Just to add to that, so it provides like open source algorithms like LEF, etc., to really look into which features and stuff, so you can really go deeper into it. The other thing is, for compliance and regulatory purposes, it has all the data, so you can go back 6 months before, look at what data, what features were used to make what prediction, and you can change those in the future as well. So it's absolutely for the great question, by the way. Thank you.
So once we create, you can see that it has created a workspace for you. What it has inside it is it creates experiments where you will be able to create experiments, pipelines, compute, etc. And you can launch the studio. I'm just going to launch the studio from here. But you can see the list of things that it comes pre-baked with. So once you are here, you can see that if you are not using the basic version, which is the enterprise version, you would see that these two features are enabled. So, or else you will see a padlock against them. So, if I look at it here, I've got a designer view. What I'm going to do is quickly create a compute for myself so that I can train my model. So I'm going to just name. So I can decide whether I want to use a GPU-based or CPU-based, whatever it is. I'm just going to go for whatever is available at the moment. Just 1, 3. That is how I want to scale that operation. And then I hit create. So there are advanced options like when do you want to set the idle time and so forth. So it starts creating that. In the meantime, what I'll do is I want to set the data source for this one. So the data store is basically where my data is coming from. So once you have cleansed your data, you can put in the data lake, I said, so or anything like that. So here I've got my data in this particular container, if you remember. And what I'm going to do is get the key for this. It's not necessarily that I have to rely on this, but if you are using ADLS Gen 2, you have the option to look into things like service principal, so which is more secure. And the blob store where exactly this can be found. So I just create that. So once that's created, I can create a data set on the back of this. It is from the one that we just created previously, and I can browse to the location. It's quite all right, I would say, given that we are working against a hotspot. So this is the data set, it says, and then I just click create. So that's my data set being created. Now let's look at a designer, which is a drag and drop interface. So there are two of them. One is a drag and drop interface, which allows you to just drag things. So I've created the data set, so I'll just drag it quickly in. As you can see, it's asking where's my compute, so I'll just say, I'm just creating this compute, just save that there. And the next thing I want to do is clean the data slightly. So I'm just going to put some cleansing process in place, things like, say, remove entire row and so forth. Then you can do something like split data. You would split the data because you want to train. Some data needs to train the model, and some data needs to go back and score your model. So that's the whole point behind splitting the data. So if you look something like this, I will just, given in the interest of time, I'll just go to one that has already been done. You would see something like this has been created, and then I select the compute, it runs. And all I then do is click run and then publish it. So when I publish, what really happens is it creates a model on the back of this. All right? Now the same thing can be done with automated ML as well. If I look over here, I can quickly create something on the back of this data set. So there's a target column. The price is what I'm trying to predict over here. It will ask me where I should be training the model. It's a regression problem. So I tell that it's a regression problem. I can define the exit criteria when it's doing automated ML. So it's using Spearman correlation. So I can say the metric should hit something like a 0.95 or something. And then I can also impute value over here. With all that being done, I will be able to create the experimentation runs. As you can see, it will give me details about my runs. And on the back of that, I will be able to just deploy the best model in there. So with all that complete, what I could then do is go back into Power BI. Once the model is published, what I could do is create a workspace, create a data flow in there, and then call my say AI insight from here. The published model would appear over here, and then I click on one of those, whether it be the automated ML one or anything related to the one that I've created on Studio. With all that being done, what I then can do is come over into Power BI and then use it as a data flow. So I'm in Power BI, what I'm doing is taking it as a data flow, and then it will evaluate, and then I will be able to create visualization on the back of it. So the final visuals, if I look over here to conclude, would look like this. So as you can see over here, it's each of the price points I've given for different car makes, and I've split the price based, the predicted and the actual price that I had to pay on each fuel type. This is the predicted value for those cars, and this was the actual value. For diesel engine, I think we got pretty much correct on that. You can see over here, this were the predicted prices, this line that you see over here, and the actual price that was paid for this one. I don't know what that one is. Let me cross-check. It is Porsche, I think so. So let's see why that is slightly out. You can see over here the price is unavailable. That could have been one of the reasons why the predicted value and the actual pricing are having a mismatch. But if you look overall, we got a pretty good track of the pricing. So you can then, as an end user, where does it all fit in is basically you could create your own model using automated ML or designer view. Does not need even a single piece of code to be written. And then you will be able to publish it for other users to make decisions on the back of it. I think as a data scientist, the key element is having the business knowledge, what you're trying to predict, what features are going to be used. If we know that, then creating the model is going to be quite easy. And what as Microsoft has done over here is making that process easy by using automated ML and the designer within the workspace. With that, we'd like to thank you for your time. And if you have any questions, just come around to the booth and we will be able to help you out. Thank you.